Okay, this is double integral part 4. I'm sorry for the third video. It's stopped by mistake, but I left it so we can continue from there. Um, I was trying to have first the x dy, which is a small rectangle over here. Then we multiply it with the height, which is f of x y. So it will be integral. If we started with x, the lower bound for x is 0, and the upper bound is a. So it's f x y dx, right? And then we integrate, we take the summation of all of these to the y dimension. So it would be from 0 to b, lower bound is 0, upper bound is b, dy, right? and, and that would be the volume. So we can find the volume in three different cases, right? We can find the x dy first and then multiply it with f of x. We can find f of x y multiplied with the x, or f of x then dy, or f of x y times the y then the x, right? So the same thing, we can find the volume of any solid shape. It depends on the numerical example we have. Let's take a numerical example over here and try to solve. Let's find a simple numerical example first. Let's take like f of x z equal f of xy, which is equal to x times y. Okay, it's a function in terms of x, y together. If you change, if I give you x or y, you give me a value of z, right? Which is x, that the value of x times that value of y. We'll do some more examples of that, but let's try to start with this at the first time. Let's try to have x condition that x is a value between 0 and 3, and y is a value between 0 and 2, right? So if I want to draw first, if I want to draw x-axis, y-axis, and z-axis, right? I don't know if it will work drawing with me. It's not easy at all to draw these three-dimensional. Anyway, we'll give it a try. Let me draw it first on, let me show you how it will be, the shape of this. Okay, let's see the shape. This is Microsoft Mathematics program. So let's graph xy, right? Z equal x times y. Enter. Okay, let me take z equal x times y, right? Let's take it in 3 dimensions. Let's see the graph. This is the graph of it. This is the graph of uh, this curve. This is the graph of z, which is equal x times y. As you can see, it's like a sheet of paper, bent sheet of paper. Okay, can you see it? Right? You can see it. If I want to find the volume, this means I'm finding the volume under this. I want to find the volume now below this sheet of paper over here, right? We want to find, we want to try to have this sheet of paper from 0 abscesses from. Okay, let me change the ordinate a little bit. This is the ordinate axis. Okay, let's see. This is z-axis, this is y-axis, and this is abscissa axis, right? Let's try to have some, I don't know, something like, I need to have simply some sheet, right? Some sheet of paper. Okay, anyway, if we want to find the area below this sheet of paper, right? First, as we did before, we can write directly the rule now. You know how to do it. But simply, if I want to find the area, the volume below this sheet of paper, right? Below this sheet of paper, I'll take some the volume, right, inside here. I'll take some x-axis and y-axis, right? Let's say the y-axis is going to be as fixed, as constant, and we take x-axis over here, right? Which is the x difference between two abscisses, right? This is 0, and this is 3, and this is 2 as the given. So, and we need to have the area of this square below that sheet of paper, right? Of this rectangle below. The area of this rectangle is going to be simply the height, which is f of xy multiplied with dx, and it's the sum of these all rectangles. It's the integral from 0, which is the lower x-axis, to 3, which is the upper x-axis, right? And when we find this, and we need to find also, we need to multiply with dy, which is this part over here, right? This part over here, which is dy, and we will have a solid volume over here, right? A solid volume, and summation of all of these in the x-axis direction and y-axis direction, it will give me the integral from 0 to 2. All of this I got, which is f of y, function in y, multiplied with dy, right? And that will be the volume of the solid shape we need to have. Or I can write it in a different way. Let me first start with the volume equal. Let me start with the volume equal